Hello and welcome to this session. This session will be looking at the integumentary system. Integumentary system is one of the 12 body systems. Guys, a link will be popping up on the 12 body systems. You can try to review them and see so that you can be able to understand how an organism effectively works based on those 12 body systems. So this integumentary system is the largest organ system, and it normally encompasses the skin and its various appendages, which include the nails, the sweat glands, sebaceous glands, and more other structures. The major layers, we have the epidermis and the dermis, okay? But also subcutaneous tissue is also counted as one of the layers, although the skin is made up of the epidermis and the dermis. The objective for this session were to define the integumentary system, to describe the structure of the skin, and to describe the functions of the skin, and lastly, to describe the accessory structures of the skin. So the skin normally covers the external surface of the body, and the surface, and this we have said that the skin is the largest organ of the body in both size, that is surface area, and weight. So this integumentary system is composed of the skin and its attachments or appendages, including the hair, the oil and sweat glands, nails, and sensory receptors. So important is the skin to self-image, self-image that make people spend a great deal of time and money to restore its to normal or youthful appearance. The skin is also referred to as the cutaneous membrane. So it covers the external surface of the body. Skin will cover about 2 square meters and normally weighs around 4.5 to 5 kgs. This is about 7% of total body weight. It ranges in thickness from 0.5 millimeters on the eyelids to around 4 millimeters on the heels, okay, on the heels. So overall, most of the body, it will be ranging from 1 to 2 millimeters thick. All right. So the structure of the skin, we can be able to appreciate our diagram. Where you can see the hair shaft. We have the epidermis, the dermis made up of the papillary layer and the deeper reticular layer. Then you have this hypodermis. This is the superficial fascia. We have the nervous structures where we have the sensory nerve fiber, the Pacinian corpuscle, the hair follicle receptor. This is the root hair plexus. Okay, then we can see the hair shaft outside the skin. So the adipose tissue is here. It's storing the triglycerides. We have the cutaneous vascular plexus, the hair follicle, the hair root is right here. Then you have the sebaceous oil glands that produces sebum, and erector pili muscles are here. We also have the skin appendages of the skin. We have talked of the Eccrine sweat glands. We have the dermal papilla in the papillary layer and subpapillary and then vascular plexus pore. So generally, the skin is made up of two major parts, and this is the epidermis and the dermis. The epidermis is the superficial and it's thin and it's composed of epithelial tissue, whereas the dermis is the deeper layer, it's thicker, and it's majorly made up of the connective tissue. If you try to compare the two, you'll find that the epidermis is avascular with no blood vessels, whereas the dermis is vascular with blood supply, right? So the epidermis has 5 layers, okay, especially in thick skin. So we have the stratum cornea that's normally made up of dead cells filled with keratin, followed by stratum lucidum. Remember, stratum lucidum will be missing in thin skin. Then you have stratum granulosum, granules, so they are made up of the lamellar granules, okay? Then you have the spinosum. Spinosum is made up of the keratinocytes. Then stratum basale. Stratum basale, this one is the most deep layer of the epidermis and it's superficial to the dermis. Okay, it gets some nourishment from the dermis. Remember, the dermis is avascular, all right? The dermis is avascular. And you can also see the nerves in the dermis, okay? That's why when you get an injury to the dermis, it's painful when compared to the epidermis, okay? We don't have really significant nerve supply to the epidermis as compared to the dermis. So, epidermis is composed of keratinized stratified squamous epithelium. And ladies, we just learned the other way how to classify epithelial cells, okay? So a link will be popping up on how to classify the epithelial cells, okay? So that we have squamous, we have columnar, we have cuboidal, and so on and so forth. In our case here, we have keratinized stratified squamous epithelium. This means that they have keratin and they are arranged in layers, so they are stratified and they are flat cells, squamous cells. Epidermis has 5 fundamental types of cells, okay? The most abundant one being keratinocytes, followed by melanocytes, Langerhans cells, Meckel cells, and lastly, stem cells. So around 90% of these epidermal cells are keratinocytes, which are arranged in 4 or 5 layers and normally produce the protein keratin. This protein keratin is fibrous and helps protect the skin and underlying tissues from abrasions, heat, microbes, and chemicals. So keratinocytes also produce lamellar granules, and these lamellar granules will be found in which layer of the epidermis? Stratum granulosum. Okay, race. So these lamellar granules, they normally release a water repellent sealant, and this sealant normally decreases water entry and loss and inhibits entry of foreign materials in the epidermis. About 8% of these epidermal cells are melanocytes, and this one they develop from the ectoderm of a developing embryo and normally produces the pigment melanin. Their long, slender projections normally extends between the keratinocytes and transfer melanin granules to them. So melanin is a yellow-red or a brown-black pigment, and this pigment normally contributes to the skin color and also absorbs damaging UV light, that is ultraviolet rays. Once inside the keratinocytes, these melanin granules will cluster to form a protective veil over the nucleus on the side towards the surface of the skin. So in this way, you find that they will shield the nuclear DNA from damage by the UV light. Although their melanin granules effectively protect keratinocytes, melanocytes themselves are particularly susceptible to the damage by UV light. The third type of cells in the epidermis is the Langerhans cells. They're also called epidermal dendritic cells, and they do arise from the red bone marrow. A red bone marrow is found in the spongy bone, all right? Yes, and they migrate to the epidermis, where they constitute a small fraction of the epidermal cells. They participate in immune responses mounted against microbes that normally invade the skin and are easily damaged by UV light. Their major role in the immune system is just to help other cells of the immune system recognize an invading microbe and destroy it. Okay? So we normally refer to them as antigen presenting cells. Okay? They just alert the other cells, hey guys, we have microbes coming in. So then the body is sensitized and the microbes are destroyed. Another group of cells, apart from the keratinocytes, melanocytes, Langerhans cells, we have the Meckel cells. And these are the least numerous of the epidermal cells. They are located deepest layer in the epidermis, where they get in contact with the flattened process of the sensory neuron. This is the nerve cell. So in that case, they form a structure called the Meckel ductile Meckel discs. And these Meckel discs and the associated Meckel discs help detect sensations. So stem cells are the undifferentiated cells that are found in the deepest layer of the epidermis. So we have how many types of cells in the epidermis? We have 5 types of cells. Number 1, we have the keratinocytes, which are about 90%. We have number 2, melanocytes, which are about 8%. Then the other percentage is made up of what? The Langerhans cells, which makes the third, and then the Meckel cells, which is the fourth, and then lastly, the stem cells, which makes up the fifth. All right, guys. We can look at the layers of the epidermis. So starting with the deepest layer, which is stratum basale, and this is the deepest layer of the epidermis. It consists of a single row of cuboidal or columnar keratinocytes. Some cells in the layer are stem cells, so they do what? They do undergo cell division to continually produce new keratinocytes. You find that the nuclei of the keratinocytes in the stratum basale are large, and their cytoplasm contains many ribosomes, a small Golgi complex, a few mitochondria, and some endoplasmic reticulum. So the cytoskeleton within keratinocytes of the stratum basale includes scattered intermediate filaments called keratin intermediate filaments, or the tonofilaments. So the keratin intermediate filaments form the tough protein keratin that is more superficial to epidermal cells. You should also know that keratin normally protects the deeper layers from injury. So the keratin intermediate filaments attach to the desmosomes. Desmosomes, these are just types of cell junctions. So, and this one, they bind with the stratum basale to each other and to the cells of the adjacent stratum spinosum. And now to the hemidesmosomes, which normally bind the keratinocytes to the basement membrane positions between the epidermis and the dermis. For the melanocytes and Meckel cells with their associated Meckel disc are scattered among the keratinocytes of the basal layer. Remember, the stratum basale is also referred to as the stratum germinatum, and this is because it just indicates its role in forming new cells. From stratum basale, we are going superficially and we go to stratum spinosum. So it's good to know that stratum spinosum is superficial to the stratum basale. I mean, stratum spinosum is on top of the stratum basale. All right. So, and this one consists of around numerous keratinocytes arranged in 8 to 10 layers. So cells in the more superficial layers become somewhat flattened. The keratinocytes in the stratum spinosum, which are produced by the stem cell in the basal layer, have the same organelles as the cells of the stratum basale, and some retain the ability to divide. Keratinocytes of this layer normally produce coarse bundles of the keratin in the intermediate filaments than those in the basal layer. So although they are rounded and large in living tissue, cells in this stratum spinosum will normally shrink and pull apart when prepared for microscopic examination, so that they appear to be like thorn-like spikes. Okay. At each spine-like projection, bundles of keratin intermediate filaments insert into the desmosomes, which tightly join the cells to one another. So this arrangement provides both strength and flexibility to the skin. Langerhans cells and projection of melanocytes are also present in the stratum spinosum. So guys, we have the stratum basale, okay, and you can see the melanocytes here. We say they are made up of 8%, yeah, of the cells in the epidermis. We have now the stratum spinosum. Stratum spinosum, you can see abundance of keratinocytes. Keratinocytes, they are going up to, so keratinocytes you see you found here, also found in the stratum basale. This makes up of around 90% of cells in the epidermis. All right, great. Then we could have now the Langerhans cells. Okay, these Langerhans cells, these are dendritic cells. These are antigen presenting cells. They just alert the other cells, hey, there are microbes here. Let's come and attack. Okay, and that immune response is activated. Then you have the desmosomes. These are just the cell junction. Okay, what connects between adjacent cells. We have the stratum granulosum. So granules. Okay, so you find cells here, they have lamellar granules. Okay. They have lamellar granules that normally produces water sealant. Okay, yeah. Then you have the stratum lucidum. This one will be missing in a thin skin. And lastly, stratum cornea, that is made up of dead keratin layer. All right. So stratum granulosum, guys. So this one is found at about the middle of the epidermis. Remember, stratum granulosum is superficial to stratum spinosum. I mean, stratum granulosum is on top of stratum spinosum. And this one consists of around 3 to 5 layers of flattened keratinocytes that are undergoing apoptosis. Apoptosis is programmed cell death. So the nuclei and other organelles of these cells begin to degenerate as they move further from their source of nutrition. And their source of nutrition is which one? The layer of the skin that is vascular. Which one is that? The dermal, the dermis. All right? Very good. So even though keratin intermediate filaments are no longer being produced by these cells, they become more apparent because the organelles in these cells are regressing. So we have a distinctive feature of cells in this layer in their presence of darkly staining granules of the protein. And this one is called the keratohyalin. It assembles keratin intermediate filaments into keratin. So as the nuclei break down during apoptosis, keratinocytes of the stratum granulosum can no longer carry out on vital metabolic reactions and they die. So thus stratum granulosum marks the transition between the deeper metabolically active strata of the epidermis and the dead cells of the more superficial strata. Alright? Correct, guys. Let's look at the stratum lucidum. And stratum lucidum is present only in thick skin. Okay? And thick skin, these are areas such as the fingertips, the palms, and the soles. It consists of around 4 to 6 layers of flattened, clear, dead keratinocytes that normally contain large amount of keratin and thickened plasma membrane. This probably provides additional level of toughness in this region of this thick skin. You just need to know that in most regions of the body, the epidermis has 4 layers, okay? Most of them. And these 4 layers are stratum basale, stratum spinosum, stratum granulosum, and then stratum cornea. But in some areas where there is exposure to friction, okay, especially the fingertips, the palms, and the soles, find that the epidermis has an additional layer, and we call them the stratum lucidum beneath the stratum cornea. All right. So stratum granulosum, we find that so we can give some of the differences between thin skin and thick skin. Now that we've said that we have introduced the concept of the thick and thin skin, it's just fair for us to try to differentiate between these two. Okay, so we can differentiate them in terms of location, in terms of epidermal layers, stratum lucidum, hair follicles, sebaceous glands, sweat glands, nerve endings, and the thickness. So thin skin normally covers most of the body surface, while thick skin will be found on the hands and soles of the feet. We have found out that the thin skin will have 4 layers, whereas the thick skin will be made up of 5 epidermal layers. You find that when you look at the thin skin, stratum lucidum will be absent compared to thick skin, which normally has the stratum lucidum present, and it's translucent between the stratum granulosum and the stratum cornea. When you look at the thin skin, you find that hair follicles are usually present. This is contrast to thick skin, where follicles are absent, or they may be very fine or not prominent at all. Thin skin will generally be present, not as prominent for the sebaceous gland, but you find the sebaceous glands are absent or sparse or rudimentary in the thick skin. The thin skin, you find that the sweat gland will be sparse or absent compared to the thick skin, where they have present and numerous, especially in the palms and soles. So nerve endings are less dense for the thin skin as compared to the thick skin, which has more dense contributing to heightened sensitivity. Lastly, we have in terms of thickness, the thin skin is about 0.5 to 0.15 millimeters. This is compared to the thick skin, which has a thickness of about 1.5 to 4.0 millimeters, which is much thicker than the thin skin. And this is very important for protection against abrasion and any other forms of friction. We have lastly the stratum cornea. Stratum cornea is superficial to the stratum lucidum in thick skin, or superficial to the stratum, yes, granulosum in the thin skin. All right. So it consists of around 25 to 30 layers of latent dead keratinocytes, but it can change in thickness from a few cells in thin skin to 50 or more cell layers in the thick skin. So the cells are extremely flat and thin, and plasma membrane is enclosed. Okay, packages of keratin are no longer contain a nucleus or any other internal organelles. They are the final products of differentiation process of keratinocytes. So constant exposure of the skin to friction stimulates increased cell production and keratin production that normally result in formation of a callus or abnormal thickening of the stratum cornea callus. All right. Then we have the concept of the keratinization and the growth of epidermis. You know that newly formed cells in the stratum basale are slowly pushed to the surface. So as the cells move from one epidermal layer, that is from stratum basale to the stratum spinosum, to the stratum granulosum, to the stratum lucidum in thick skin, and then finally to the stratum cornea for both thin and thick skin, they do accumulate more and more keratin, and this process is referred to as keratinization. So once they have done this, they undergo apoptosis, which you have referred to as programmed cell death. Eventually, keratinized cells will slouch off and are replaced by underlying cells that in turn become keratinized. So the whole process by which cells from the stratum basale rise to the surface, become keratinized, and slouch off takes around 4 to 6 weeks, and in an average epidermis of 0.1 millimeters thick, right? So from there, we look at now the dermis. Remember, we are done with the epidermis. So the dermis, and this dermis only has 2 layers, and we abbreviate them as what? PR, papillary and reticular layer. So the dermis is the second deepest part of the skin, and is composed of dense irregular connective tissue containing collagen and elastic fibers. So this woven network of fibers has a great tensile strength, which helps it resist pulling or stretching forces. The dermis also has the ability to stretch. They stretch and recoil easily. It is much thicker than the epidermis if you compare, and this thickness varies from region to region in the body, reaching its greatest thickness on the palms and the sole. So the few cells present in the dermis, we have fibroblasts. Remember, for the epidermis, the cells were which one? Keratinocytes, very good. Melanocytes, very good. Langerhans cells, very good. Merkel cells, wonderful, and lastly stem cells. Now for the dermis, we have predominantly fibroblasts with some macrophages and a few adipocytes near the boundary between the subcutaneous tissue. All right, great. So we have blood vessels and nerves and glands and hair follicles embedded in the dermal layer. Remember, we had said that the epidermis is vascular, the dermis is vascular. Very good, guys. And you're saying if someone gets an injury in the dermis, it will be painful as compared to the epidermis, and because of this. So the dermis is essential for the survival of the epidermis. That is true. And these adjacent layers are very important, whatever. So based on this structure, the dermis is divided into a superficial layer, which is papillary, and a thicker, deeper reticular layer. I request we start by looking at the superficial papillary region, and this normally makes up around 1/5 of the thickness of the total layer. It consists of the thin collagen and fine elastic fibers. So its surface area is greatly increased by the dermal papilla, small nipple-shaped structures that project into the undersurface of the epidermis. So we have different and free nerve endings, normally initiate signals that give rise to sensation of warmth, coolness, pain, tickling, and itching. The deeper layer, which is the reticular layer, is attached to the subcutaneous layer and consists of thick collagen fibers, scattered fibroblasts, and various wandering cells. We call them the wandering macrophages. All right. So some adipose cells can be present in the deepest part of the layer, along with some coarse adjust elastic fibers. Remember, guys, we should never lose our track. We were looking at the epidermis, and here we are saying that cells that produce pigment and protect the immune system. We have already looked at the epidermis. We are now looking at the dermis, which contains nerve endings, oil, sebaceous, hair, and blood vessels. All right. Remember, subcutaneous tissue, though not part of the skin, okay, it's made up of fat, connective tissue, and large blood vessels. All right. Correct, guys. So now we can look at the structure of the structural basis of the skin color. Where do you get your color? Where does your color come from, guys? Saying that we have three pigments that normally impact a variety of colors to the skin. Number one, we have melanin. Number two, we have hemoglobin. And three, we have carotene. So the amount of melanin causes the skin color to vary from pale yellow to red-brown to black. The difference between the two forms of melanin, we have pheomelanin, this is yellow to red, and eumelanin. Eumelanin, this is brown to black and is most apparent in the hair, okay? Excuse me. So, the melanocytes, this one they normally produce melanin cells, okay, are more plentiful in the epidermis of the penis, the nipples of the breasts, and just around the nipples, the face, and the limbs. They are also present in mucous membranes, and because of the number of melanocytes is about the same in all people. The differences in the skin are mainly due to the amount of pigment the melanocytes produce and transfer to keratinocytes. You find for dark-skinned individuals, they have large amount of melanin in the epidermis. So their skin ranges from yellow to red, brown to black. While light-skinned individuals, they have little melanin in the epidermis. So thus, the epidermis appears translucent and the skin color ranges from pink to red depending on the oxygen content of the blood moving through the capillaries into the dermis. Let's look at the accessory structures of the skin, guys. And this one includes the hair, the skin glands, nails. Remember, they develop from the embryonic epidermis. So we have the hair, oils, sweat glands, and the nails. All right. So let's look at hair. Hair or the pili, these are present on the most skin surfaces, except on the palms, okay? On the palms, on the palmar surface of the fingers, the soles, and the plantar surface of the feet. In adult, you find that hair usually is most heavily distributed across the scalp, in the eyebrows, in the axilla, or those are the armpits, and around the external genitalia. So genetic and hormonal influences largely determine the thickness and the pattern of hair distribution. But although the protection of it offers is limited, hair on the head normally guards the scalp from the injury and the sun rays. It also decreases heat loss from the scalp. Eyebrows and eyelashes do protect the eyes from foreign particles. Similarly, the way hair in the nostrils and the external inner ear canal defend those structures. All right. So on the structure of the hair, we have the hair shaft, we have the erector pili muscle that helps the contraction and relaxation, and then sebaceous glands, we have the hair roots, the hair bulb follicle. So we have touch receptors. These are hair root plexus that are associated with hair follicles, are activated wherever a hair is moved even slightly. Thus, hair also function in sensing light touch. So each hair is composed of columns of the dead keratinized epidermal cells bonded together by extracellular proteins. So the shaft and the root of the hair both consist of three concentric layers of the cells. You have the medulla, cortex, and the cuticle of the hair. What about the skin color? The color of the hair is primarily due to the amount and type of melanin in its keratinized cells. So melanin is normally synthesized by melanocytes scattered in the matrix of the bulb and passes into the cells of the cortex and the medulla of the hair. So for dark colored hair, it contains mostly eumelanin. Okay, this is the color will range from brown to black, and blonde and red. Red hair contains variants of pheomelanin. This will range from yellow to red. So hair becomes gray because of progressive decline in melanin production. So gray contains only a few melanin granules, while white hair results from lack of melanin and the accumulation of hair bulbs in the shaft, right? Skin glands. So glands are epithelial cells that normally secrete substances. So we have several kinds of exocrine glands are associated with the skin. We could have the sebaceous oil glands, the pseudoferous sweat glands, and we have the ceruminous glands. Remember, mammary glands, which are specialized pseudoferous glands, do secrete milk. So we could have the difference between exocrine glands and endocrine glands. So for the endocrine, exocrine, we have secretions are released into ducts or surfaces such as the sweat, saliva, digestive enzymes. This is compared to endocrine where secretions or these are hormones are released directly into the bloodstream. So exocrine glands have ducts, so secretions are transported through ducts to the specific target areas. Whereas endocrine glands lack ducts, so secretions are released directly into the bloodstream and are carried to the target organs. When you look at the target site, you say that exocrine glands they have their target site as the specific organs, body surfaces, or cavities, whereas the target organs and tissues throughout the body are present for the endocrine glands. In terms of examples, for exocrine glands, we have the sweat glands, salivary glands, digestive glands, mammary glands. For the endocrine glands, we have the pituitary gland, okay, thyroid gland, adrenal gland, pancreas, ovaries, and testes. When you look at the mode of action, you find that exocrine glands, the chemical signals are delivered through ducts to target areas. Whereas the endocrine glands, we have chemical signals, hormones are carried in a bloodstream to target cells or organs. When you look at the response time, okay, exocrine glands generally, the response time is generally faster response time, okay, sometimes seconds to minutes. While endocrine glands, we have response time may be slow. It may take minutes to hours. However, they can have prolonged effects. In terms of regulation, exocrine glands are regulated by neural or hormonal signals, whereas endocrine glands, they are regulated by feedback mechanisms involving hormones and hypothalamus pituitary axis. So we could have negative feedback and positive feedback. So enzymes, sweat glands, mucus, oil, digestives are examples of secretions for the exocrine glands, whereas insulin, cortisol, estrogen, testosterone, growth hormones are examples of secretion produced by the endocrine glands. So from there we have the sebaceous gland, and sebaceous glands are oil glands. They are simple branched acinal or rounded glands. With a few exceptions, they are connected to the hair follicle. So their secreting portion normally lies in the dermis and usually opens into the neck of the hair follicle. Some locations such as the lips, glans penis, labia minora, and tarsal glands of the eyelids. Sebaceous glands do open directly into the surface of the skin. So sebaceous glands are absent in the palms and soles. Sebaceous glands are small in most areas of the trunk and limbs, but they are large in the skin of the breasts, the face, neck, and superior chest. Sebaceous glands do secrete oily substance referred to as the sebum, which is a mixture of triglycerides, cholesterol, proteins, and inorganic salts. So sebum does coats the surface of the hairs and helps keep them from drying and becoming brittle. Sebum also prevents excessive evaporation of water from the skin and keeps the skin soft and pliable and inhibits growth of some bacteria. For the sudoriferous glands, we are saying that these are about 3 million to 4 million sweat glands in the body. So the cells of these glands release sweat or perspiration into the hair follicles or into the skin surface through pores. So sweat glands are divided into two main types. We have eccrine and apocrine. Apocrine, based on the structure and type of secretions. As for the eccrine sweat glands, they are simple, coiled tubular glands that are much more common than apocrine sweat glands. They are distributed throughout the skin of the most regions of the body, especially in the skin of the forehead, palms, and soles. You find that eccrine sweat glands are not present, however, in the margins of the lips, nail beds of the fingers and toes, glans penis, glans clitoris, labia minora, or the eardrums. The secreting portion of eccrine sweat glands are located deeply in the deep dermis, sometimes the upper subcutaneous tissue. The excretory products projects through the dermis and epidermis and ends up as spore at the surface of the epidermis. So the sweat produced by eccrine glands is about 600 mils per day, and it consists of water and ions. The ions are mainly sodium ions and the chloride ions. We also have urea, uric acid, ammonia, amino acids, glucose, and lactic acid. So the main function of the eccrine sweat gland is just to help regulate body temperature through evaporation. So as sweat evaporates, large amounts of heat also leave the body surface. The sweat glands by eccrine glands also play a role in eliminating waste such as urea, uric acid, ammonia from the body. All right. So next we can look at now the apocrine glands, sweat glands. Okay, they are also simple and coiled tubular structures. They are found mainly in the skin of the axilla, that's the armpit, groin, areola of the breast, and bearded regions of the face in the adult skin. So these glands were once thought to release their secretion in apocrine manner by pinching off a portion of the cell. Apocrine sweat glands contains the same component as eccrine sweat plus lipids and proteins. So the sweat produced from apocrine glands is usually odorless. However, when the apocrine sweat interacts with the bacteria on the surface of the skin, the bacteria metabolizes its components, causing apocrine sweat to have a musky odor that is often referred to as the body odor. So apocrine sweat glands do not begin to function until puberty. Okay, this is different from the eccrine, which normally start working at birth. So in contrast to thermoregulatory sweating, emotional sweating first occurs on the palms, soles, and axilla, then spreads to other areas of the body. Apocrine sweat glands are also active during emotional sweating. Right? The other type of gland is the ceruminous glands, and these are modified sweat glands in the external ear. They do produce a waxy lubricating secretion, and the secretions of the ceruminous glands lie in the subcutaneous layer deep to the sebaceous glands. Their secretory ducts open directly into the surface of the external auditory canal or into the ducts of the sebaceous glands. So the combined secretion of Ceruminous and sebaceous glands is a yellowish material called cerumen or earwax. So cerumen together with the hair in the external auditory canal provides a sticky barrier that impedes the entrance of foreign bodies and insects. So cerumen also waterproofs. It also waterproof the canal and prevents bacteria and fungi from entering the ear. So we could have a summary of some of these glands. We have the Moebius glands found on the eyelids. We have the Ceruminous glands, mammary glands, Apocrine glands, and Eccrine glands. All right. What about the nails, guys? Saying that the nails, these are plates of tightly packed, hard, dead, keratinized epidermal cells. Right? This one that they form a clear solid covering over the dorsal surface of the distal portions of the digits. So each nail consists of a nail body, free edge, and a nail root. Okay. So you have the edge of the nail, nail plate, lateral nail fold, lunula, and the cuticle. Then you have the proximal nail fold. Right. Correct. So nail growth also varies according to the season and the time of the day and environmental temperature. Right? We find that averagely the growth in the length of fingernails is about 1 millimeter per week. So the growth rate is somewhat slower in the toenails. We have a number of functions for the nails. They do protect the distal end of the digits, right? And they also provide support and counter pressure to the palmar surface of the fingers to enhance touch perception and manipulation. Lastly, they do allow us to grasp, okay, and manipulate small objects, and they can be used to scratch and groom the body in various manner. So let's now finally look at the functions of the skin. So the function of the skin, number one, we have thermoregulation, and this is the homeostatic regulation of the body temperature. So the skin contributes to thermoregulation in two major ways. That is number one, liberating sweat at its surface, and number two, adjusting the flow of blood in the dermis. So remember, in response to the high environmental temperature or heat produced by exercise, sweat production from the Eccrine glands increases. And the evaporation of sweat from the skin surface helps lower body temperature. In addition, blood vessels in the dermis of the skin will dilate. Consequently, more blood flows through the dermis, so which increases the amount of heat loss from the body. In response to low environmental temperature, we have production of sweat from the eccrine is decreased, which helps conserve energy. Likewise, the blood vessels in the dermis of the skin will constrict, which decreases blood flow through the skin and reduces heat loss from the body. Also, the skin serves as a blood reservoir. Okay, the skin may act as a blood reservoir by holding about that is 8 to 10% of the body's blood, which may be diverted to other areas of the body should the need arise. So when the other body organs such as vigorously working muscles need a greater blood supply, the nerves constrict the dermal blood vessels, shunting more blood into the general circulation, making it available to the muscles and other body organs. Next, we have the protection, and we know that the skin provides protection to the skin in various ways, and keratin does protect the underlying tissues from microbes, abrasions, heat, chemicals, and the tightly interlocked keratinocytes resist invasion by microbes. So lipids released by these lamellar granules do inhibit evaporation of water from the skin surface, thus guarding against dehydration. They also retard the entry of water across the skin surface during showers and swimming. The oily sebum from the sebaceous glands keeps skin and hair from drying out and contains bactericidal chemicals. Also, The acidic pH of perspiration, that is the sweat, retards the growth of some microbes. The pigment melanin also helps shield against damaging effects of ultraviolet. So, the two types of cells that carry out protective function that are immunologically in nature. We also have the epidermal Langerhans cells, those dendritic cells, the APCs. They do alert the immune system in the presence of potentially harmful microbial invaders. By recognizing and processing them, and macrophages in the dermis will phagocytose the bacteria and viruses that damage or manage to bypass the Langerhans cells in the epidermis. So that's how the skin carries out the function of protection. What about the skin as an organ for cutaneous sensations? We're saying that these are sensations that arise in the skin and include tactile sensations, touch, pressure, vibration, and tickling, as well as thermal sensations such as warm and coolness. So another cutaneous sensation, pain, usually is an indication of impending or actual tissue damage. So this is a wide variety of nerve endings and receptors distributed throughout the skin, including the tactile discs of the epidermis, so the capsules of the touch in the dermis and the hair root plexus around each hair follicle. Next, we have the skin as an excretory organ and also best for absorption. The skin normally has a small role in excretion, that is elimination of waste from the body, and absorption, the passage of materials from the external environment into the body cells. So despite the almost waterproof nature of the stratum cornea, we still have 400 mils of water evaporating through it daily, right? So beside removing the water and the heat from the body, sweat also is a vehicle for excretion of small amount of salts, carbon dioxide, two organic molecules that result from the breakdown of proteins, that is the ammonia and urea. So the absorption of water-soluble substances through the skin is negligible. But certain lipid materials do penetrate the skin. For example, the fat-soluble vitamins, ADEC, certain drugs and gases such as oxygen and carbon dioxide do penetrate. So toxic substances that can be absorbed through the skin include organic solvents such as acetone and carbon tetrachloride, okay? Source of the heavy metals such as lead, mercury, arsenic, and substances in poison ivy or poison oak. Next, we have the synthesis of vitamin D, okay? So synthesis of vitamin D requires activation of a precursor molecule in the skin by the ultraviolet rays. So enzymes in the liver and the kidney then modify this activated molecule, finally producing calcitrol, which is the most active form of vitamin D. Calcitrol, remember, it's a hormone that will aid in the absorption of calcium from foods in the GIT in the blood. So only a small amount of exposure to UV, that's around 10 to 15, at least twice in a week, is required for vitamin D synthesis. So most cells of the immune system have vitamin D receptors, and the cells activate vitamin D in response to an infection, especially a respiratory infection such as influenza. So vitamin D is believed to enhance phagocytic activity, increase production of antimicrobial substances in the phagocytes, regulate immune functions, and help reduce inflammation. Also, the skin helps in the function of another function, the immunity. It has a role in ensuring the immunity of an organism. So, first of all, it works as or presents as a physical barrier. You know, the epidermis consists of these tightly packed cells and the layers of the lipids. So this forms a physical barrier that prevents entry of pathogens into the body. Pathogens will have a difficult time penetrating this layer, protecting the body from infection. Also, the acidic nature of the skin. You find that the skin is slightly acidic, okay, with pH typically ranging from between 4.5 to 5.75. And this is due to the presence of sweat and sebum. So this acidic environment will inhibit the growth of many bacteria and fungi. thus act as a natural antimicrobial defense mechanism. Okay. Also, another role for the skin in terms of the immunity is this commensal or microorganisms. You know, the skin is a home for diverse community of beneficial microorganisms. This one that we normally refer to as skin microbiota. So they normally outcompete harmful pathogens, preventing their colonization and growth on the skin surface. So this complex exclusion helps the skin health, helps maintain the skin healthy and keeps off in the infections. In terms also of the immune cells, you find that specialized immune cells such as Langerhans cells and dendritic cells present in the epidermis act as antigen presenting cells. So they do what? They capture the antigens, these are the foreign substances, and present them to the T cells, initiating an immune response. Langerhans cells are particularly crucial in recognizing and responding to invading pathogens. Also for the inflammatory response, when the skin is injured or breached, the body initiates an inflammatory response. So immune cells are attracted to the site of injury or infection, helping to neutralize, eliminate pathogens. Inflammation also increases blood flow to the affected area, enhancing delivery of immune cells and antibodies. Next, we have antimicrobial peptides. So the skin produces various antimicrobial peptides, small proteins that can kill bacteria, viruses, and fungi. So these antimicrobial peptides are part of the innate immune system and do provide rapid protections against a wide range of pathogens. Lastly, we have this skin-associated lymphoid tissue. We abbreviate it as SALT. And this one refers to the cluster of immune cells located in the skin's underlying connective tissue. These cells include T cells, B cells, and macrophages. And they actively participate in immune response against pathogens that normally breach the skin integrity, right? Okay, guys. So, guys, we have come to the end of the session, guys, and we can take this opportunity to look at the review questions. State areas where the eccrine sweat glands are mainly found. Also, the layer of the epidermis that contains stem cells undergoing mitosis is. We need also to define the skin, state three functions of the skin, identify the cells of the epidermis. Guys, I hope this lecture has been informative and helpful to you. I'll urge you to go to the description section of this video. You'll find a quiz for practice, and this quiz should